So once again, good morning all of you. This is your course instructor, Khushwant Fatnani. Let us start the class for the day where we are revising the syllabus for JEE and NEET 2020. Let us start off with the session. Before we do, like always, let us join our hands, close our eyes, and take 3 deep breaths one by one. Count 1. Deep breath in and out. Breathe in and slowly, with a smile on the face, breathe out. Every incoming breath energizes the mind. Every outgoing breath relaxes the body. Once again, take a deep breath in and allow the deep breath out. I am remembering my gurus who have given me this knowledge. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwarai, Gurur Sakshat Parabrahma, Tasmai Shri Guruve Namah. Now let us all pray together. Pray together. Dear God, we thank you for this life. We thank you for all the miracles of life, for such good health, wealth, and wisdom. We thank you for receiving all the support, guidance, and motivation from our mentors, families, and friends. We are grateful. Dear God, I thank you in advance that you have assisted me, and with your grace, I have been able to work hard and clear NEET 2020 and JEE 2020 in flying colors and have got admission into the best college of my dreams. Thank you in advance, dear God. Thank you, thank you, thank you. Let a smile on the face stay, and with a deep breath in and out, you may slowly open your eyes. Let's start. So, we'll continue with a session where we were revising, where we are revising the syllabus, right? So, let us start class. So I remember yesterday we were doing in the last class a law called as Galileo's law of odd numbers. For those who would like to revise, Galileo's law of odd numbers states that whenever there is an object which is falling from the state of rest on a surface, let's say over here, right? This object starts falling, let's say a small particle or a ball. Now it's falling from rest to the ground, what will happen? The law says that the distances covered in equal intervals of time, I'll repeat, the distances covered in equal intervals of time are in the ratio of odd numbers. So let us say in first time interval t, it covered the distance as shown by the black line. Then in the next time interval t, it covered the distance shown with the brown line. And then finally, again in the next t seconds, the distance covered is shown by the blue line. So these distances, which I'm denoting by h1, h2, and h3, they are basically distances traveled in first t seconds, then distances traveled in the next t second, and distance traveled in the next t seconds. They are in the ratio h1 is to h2 is to h3 is equal to 1 is to 3 is to 5. And in fact, if we have more number of such distances, they are certainly in the ratio 1 is to 3 is to 5 is to 7 is to 9 and so on, right? I hope you all are clear with this. So we were about to solve a question on this. Let us see the same on the other side. So here we go. So this question is from NEET again. Yes, class, kindly note down this question. A very interesting one. It's from NEET 2013. Please have a look. A question on the basis of this from NEET 2013. The question says, a stone falls freely under gravity. A stone falls freely under gravity. Whenever you're given in the question that anything is having a free fall, so stone falls freely under gravity, right? This is given to us. Whenever you're being told falls and there is nothing else given, you will assume that the initial velocity is 0. Next it says it covers distances h1, h2, h3. It covers distances h1, h2 and h3 in the first 5 seconds, in the first 5 seconds, next 5 seconds, and next 5 seconds respectively, right? You're being told the relation between h1, h2, h3 is, the relation between h1, h2, h3 is. So the relation between h1, h2, h3 is, right? You are given with the options A, B, C, and D in this manner, right? This question is not only important when it comes to just the physics of it, but it's also important when it comes to the mathematics of it. Mathematics is easy, but at the same time, a little tricky in this question. Let's see if all are able to link what I have read to what is given. I would want you all to take a minute and try solving it. Yes, go ahead, everyone. Meanwhile, I'm writing the options. Try solving this and let me know your answer on the same. Yes. Yes, class, get going. right? I hope all of you have given attention to the question. So have a look how will we solve it, right? Right? So have a look how we're going to solve it. We're going to solve it in this manner. See, the first thing we are being told that try relating it. So see here, I'll bring my spotlights. Yeah. So have a look in the first 5 seconds, in the first 5 seconds, in the next 5 seconds, and in the next 5 seconds, the distances have been given as h1, h2, h3, right? So here, have a look here. Instead of 5, I had just written t seconds, t seconds, and t seconds, right? So the question is just a direct application of this law. All we are going to do is instead of capital H1, capital H2, and capital H3, we just have a small change of the variables which we have used, right? And everything else remains the same. Have a look. So according to the question, H1 is to H2 is to H3 are in the ratio 1 is to 3 is to 5, right? Now, how do you find the relation between them? In such cases of ratio, you always feel free to take H1 as K. If H1 is K, then H2 will be 3 times of K. H3 will be 5 times of K, right? Now, see, have a look. How do you actually relate it then, all three of them? Let's try relating. Now, if H1 is K, right, I can write H2 is equal to 3 times of H1, right? In a similar fashion, I can write H3 is equal to 5 times of H1. What does this mean? Try calculating H1 from here. This equation which I have shown with the arrow, H1 is equal to H2 by 3, right? From the second equation, let me take this with a blue arrow. Try writing again H1. H1 is equal to H3 by 5. Now you can easily relate the three variables in one equation. Have a look. We will have H1 is equal to H2 by 3, H2 upon 3 from over here. Then this H1 is also equal to H3 upon 5. And you can clearly see second option fits with this answer, right? I will see, have a look. All we did, which is just see what the ratio is, take the values in the given format, and then one by one arrange it as given, right? And then equate the three equations, right? So all it was a simple play of mathematics, nothing much. So those who are clear with the question, class, please raise your hand so that I'll know that you're clear and we'll go to the next question. Yes, please raise your hand if you're clear with the application. Yes, class. All right, so I can see that you all are clear. Excellent. I'm happy to know. I think Siddharth, you have just entered the class. No worries. Please make sure that you have a look at this lecture in the YouTube section so that you can have a session of it. So Siddharth, welcome to the class. In case you have joined just now, have a look. We had a discussion on what is Galileo's law of odd numbers, right? And since this session is being recorded, it will be available for all of you to view on the channel, uh, Physics with Fatnani, right? And this will be the sixth lecture of the same, so you all can easily access the lecture as many number of times as you wish. So let's move to the next part, right? So class, I would like you all to practice thank you everyone, you can bring your hands down. I would want you all to keep practicing questions, especially from the vector based format of the questions from the past years. So giving you all one more question. Have a look. The question says, or even there are some questions which are based on the format of uh, two-dimensional motion. Have a look. This is question from, again, motion in 2D, AIEEE 2010. So the question says a small particle of mass m, right? There is a particle of mass m what happens to it? It is projected at an angle. It is projected at an angle theta with the x-axis. See, this way, right? With an initial velocity of v naught, and the angle which it makes with x-axis, let's say this black color line is representing the x-axis. The angle which it makes with the x-axis is theta, right? Now, in the xy plane as shown in the figure, so basically they have given a figure in the question this manner, where the stone is being projected from the origin, right? So you have, this is x-axis, this is y-axis, right? And from here the stone has been projected. It is saying that at time t less than v naught sine theta by g, the angular momentum of the particle is, angular momentum of the particle is, right? So you're being asked the angular momentum. How do you solve such a question? Class, try recalling. You must have read that angular momentum, right, is nothing but the cross product of position vector and momentum, right? That is r cross p. It is an angular, it is a vector quantity given as r cross p, right? And since p is nothing but mv, you can write this as r cross m into v, where take maybe m outside it, and you will get this as m into r cross v, right? This is what angular momentum is, and you are being asked what is the angular momentum of the particle before t less than, this v naught sine theta by g. Now, class, try recalling. Yesterday, I had given you some important takeaways from the ground to ground projectile, right? Try recalling that we had read how much time does this projectile takes to reach its zenith. Try recalling. Tz or T zenith was equal to uy by g, right? In case you all can recall, right? So in case there is anybody who would like to help me with this, okay, so let us take Harsh. Yes, Harsh. I think Harsh, you have raised your hand. Yes, Harsh, let me know. You want to know something, Harsh? You want to ask something? Please do. Yes, go ahead. Okay, I'll unmute everyone. Yeah. Yes, Harsh. Tell me. Harsh, is there something you want to ask? Okay, no worries. Okay, anyone, can you help me with this? Let's take Shivani. Yes. So, Shivani, can you tell that what is the value of uy for this particular question? Can you try calculating the component of velocity along the y direction? It is v naught,
Sine theta.
v naught
V naught
sine.
sine theta.
Absolutely correct. Now, we put this in the formula of t zenith. What will it become? Uy by g, therefore becomes, yes, v naught sine
V
theta
naught sine theta
by
upon G.
g. Absolutely correct, Shivani. So we have the time taken to reach this point is t zenith. That is at, so if say motion started at t is equal to 0 from the origin, this is the origin, let's say O, right? So here the particle reached its maximum height at t is equal to t zenith, which is v naught sine theta by g. So when I'm being told find the angular momentum at a time less than this time, that means t less than t zenith. It means that we have to find the angular momentum. I'll repeat, it means that we have to find the angular momentum of the particle as it is going along this path, which I just highlighted with green color, right? Am I correct, Shivani? Can you cross check what I've just said, right?
Yes, sir.
So we are supposed to find out what is the
Yes, sir.
angular momentum of the particle as it is in its first phase, that is the first half of the projectile motion, right? Now, let us say our particle is placed at any random point. Let us consider this point, or maybe I'll take a red color point to denote the position. Let's say the particle is over here, right? Now, how do you write the position of the particle? Try recalling. Shivani, can you tell me how do we write R? R is given by, the position vector is given by x I cap plus y j cap, right?
Yes, sir.
Y j cap, correct?
J.
Now, yesterday we all had come up with, or we had all had understood that it's very easy if you can denote the different directions or different uh, variables in x and y directions separately. So try recalling, we have one expression here, s is equal to, I'll write first the general expression and then that expression in terms of x and y coordinates. So let's say we had the expression x is equal to ut plus half at square. Try recalling, there is no acceleration in the x direction. There is only one acceleration acting, that is in the downward direction along y axis, right? Which is
Downward direction.
right, which we are taken as minus g. Now, Shivani, how will we denote s in terms of x, right? Right? Now we can write x is equal to uxt because ax is 0. So this second term will not exist for the x coordinate, right?
Yes, sir.
So we'll write it in that manner over here. So we'll have x is equal to uxt. After writing this, can I substitute it over here? Do I know ux? Shivani, what is ux? V naught
Sir, we not cos theta.
cos theta. Absolutely correct. So we'll have x is now given in terms of t as u naught cos theta t. Easy, right? We'll put this here, u naught cos theta t, right? I cap. Now, how about y? Let's see what is y. Y will be given as, yes, Shivani, uyt, right? Minus half g t square. Am I correct, Shivani, in
Minus
writing,
half. Yeah.
right?
Yes, sir.
Now, substitute the value of uy from here. What will it become? The value of y? Yes,
V not sin theta.
v naught sine theta minus half gt square. Correct? Now, let us
Yes, sir.
substitute the same over here. We'll have this, instead of y, we will write v naught sine theta,
V not
right? Yes,
sin theta minus half
minus
gt square.
half gt square. Absolutely correct, Shivani.
Gt
Times of j cap. Now, what do we have to do? We have been given with r. Do we know how can we write velocity v? Yes, we can. See, we know that again. I will write the expressions for velocity in terms of x and y separately. We know the formula. What is the formula for velocity, Shivani? Yes.
dx by dt.
Yeah, this is one. In case acceleration is constant, in that case, from the first equation of uniform motion, v is equal to
Or u plus at.
u plus at. Absolutely correct. And if we write this formula now in terms of x and y coordinates separately, see here. So we'll write this formula in terms of x and y coordinates separately. That is, we will write value of first vx. Vx will be equal to ux plus axt, and here we'll have vy is equal to uy plus ayt. Right, Shivani?
Yes, sir.
Now the value of ax is 0 or
0.
non-zero? Zero. Absolutely correct.
0.
Very good. Then what about ay
Minus g.
minus g? Absolutely correct. So here we'll have vx is nothing but ux. We had taken this as a derivation yesterday, right? So this is nothing but
Yes, sir.
u cos theta, right? Correct.
Yes, sir.
Now how about vy? Vy will be, instead of u cos theta, we can write here v naught cos theta, right? Now how about here uy is v naught
V not sin theta.
sine theta, absolutely correct, minus gt. Can we write it this way, Shivani?
Yes, sir.
Right? So let's do it. So now we have the value of vy, we have the value of vx. Let us write v in terms of vx I cap and then we'll have Vy j cap. Why have we written this way? Matlab, there is no rocket science here. We all know that any vector is always represented. Suppose V is the vector, then we always represent any vector in terms of its x and y component, always in this format. Am I clear? Am I right, Shivani, in saying this, right?
Yes, sir.
So we'll have V naught cos theta I cap
V naught cos theta I cap
plus
plus
V naught
sin theta
sin
minus
theta
GT
minus gt.
J cap.
Yes, G cap. Absolutely correct. So now let us substitute the values of R vector, right? R vector and V vector in this expression, and we will get the answer. Am I right, Shivani? Correct?
Yes, sir.
So now I hope you all are very well aware how do you actually take a cross product. Still, I'll give a short understanding of it in 1 minute. Yeah. So we have got now what is the position vector and what is the velocity vector. Let us take the same here. Whenever we take, so here we are calculating L, which is given as M into R cross V. We know that cross product is given by M times of, in the determinant form, this will be given as, right? This will be given as I cap, J cap, K cap, correct? Then you can have Rx, Ry, Rz, and here Vx, Vy, Vz, right? Now we have M into, and one by one you can substitute the values of Rx, Ry, Rz from here, Vx, Vy, Vz from here, and I'm sure you all will get the answer. So here in the question, since we do not have the Z component of velocity and position vector, you can take it 0, right? So basically you can also reduce this vector in terms of just I and J. Basically this cross product in terms of I and J. Am I correct, Shivani?
Yes, sir.
Right? I hope you all can take the cross product, try it out. In case any doubts, please consult me. Let me know. Right? So your
Yes, sir.
answer for this question will come out to be minus half m t v naught t square cos theta k cap. Class, please try it out. I'm sure you all are going to get the answer. Just make sure you remember that I cross j is given as k, and so on. There is a anti-clockwise and clockwise rule here. Whenever you take I cross j, you will get k. Whenever you take j cross k, you will get I. Whenever you take k cross I, you will get j. Right? I hope you all know this. And when we have done this, suppose we take the opposite way. That is, if we take j cross I, we will get minus k. I hope you all are aware with this, right, Shivani? The rules of
Yes, sir.
taking cross product of the unit vectors. Now, let us move to the next question. Thank you, Shivani.
Sir, I have a doubt.
Yes, 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 Shivani, tell me.
Sir, why we have not differentiated R vector to get V?
Because,
Why we have used this
because,
motion?
because try recalling when did we use the differentiation funda? We used the differentiation funda when the quantity being differentiated was variable, right? When it was variable. And even if you want to do it, you may do it, but see here, the x component, it's varying with time. Try recalling, you will get the answer. Definitely you can do whenever you will find, whenever. So I'll bring it here. See here, let's take Rx as, I'll write it here, V naught cos t, V naught cos theta dt. Try taking a differentiation of it. Try it that way. See, do you get the answer? In case yes, you can go ahead with it. We'll have V naught cos theta t. You'll get the answer. See, do you get this? Yes, right? Right, Shivani?
Yes, sir.
You'll get the answer. Now, similarly,
Yes,
for
sir.
this component, again try differentiating it. See if you get this answer or not, right? So basically the point is, I think this will be ut, right? So basically the point is, make sure that you, this will, here also there'll be a t, make sure that you try this question by different ways, Shivani, as you just said. I have just adopted one of the technique. This does not mean that there is just one technique for this question. You can solve this question ample number of ways. So whenever, class, remember, whenever we have r given as something a function of t, you can always differentiate it in order to get the value of v in respective x and y components. Yes, you can do that. And Shivani, just as you told, you can always take this funda over here, provided this r is a function of time, which is applicable in this case. So yes, you can go ahead with it, no worries. Excellent, Shivani, excellent that you thought of it, really appreciate it, right? So what I have written is just one of the techniques, so it also means that there might be other techniques available. Am I clear, Shivani?
Yes, sir.
Right? So even your approach is correct, the one which we adopted yesterday, that if we can write r in terms of x and y, so say x I cap plus y j cap, right? And we can write v as vx I cap and vy j cap. So if we see that x and y are functions in time, that is variable with time, then we can differentiate them and write the values of Vx and Vy. Absolutely correct, Shivani. We can definitely go that way. Definitely. Right? Am I clear, Shivani? Is your doubt solved?
Yes, sir.
Right. Thank you. So, class,
Thank
anybody
you, sir.
else? Right. Class, anybody else with any query, please let me know. Okay, I think Siddharth. Okay, so Siddharth has conveyed that he was present in the class. Uh, okay, and because of the power cut he had got locked out. Okay, thank you, Siddharth, thank you for letting me know. Okay, right, so no worries. I hope you have heard the lecture. In case there is any issue, class, you all can always approach me, right, and let me know if there are any queries with any doubt in the question, right? So class, now for all of you, I would like to take one simple concept, although we had taken it in yesterday's class, but the question is in the concept of circular motion, right? That in any circular motion which is uniform and non-uniform, we had seen how things work, a quick revision, and then some other concepts related to circular motion. So have a look whenever we are talking about circular motion. Circular motion. So when we are talking about circular motion, what is circular motion? Any body which is traveling in a circular path, right, such that its velocity is always along the tangent. Its velocity is always directed along the tangent to that circle, right? So here, this is how the velocity is directed, right? Let us say the radius of this circle, the radius of this circle is equal to r. Let us say it is r, right? Now this is how the velocity is directed, this is how the circular motion takes place. Now yesterday we had talked of a special scenario, uniform circular motion. What does uniform circular motion mean? So when I'm talking about uniform circular motion, or UCM, right, in a uniform circular motion, the concept is that speed remains constant. Speed remains constant, remains constant, right? And velocity is variable, as well as speed is variable, right? Speed is variable. We had covered a concept yesterday that whenever we talk about change in velocity, so suppose if the ball is over here, suppose that particle is over here, we had seen that if we take the right side to be x-axis, the top side to be y-axis respectively, then if the direction of velocity is towards right, we will say that the velocity, let's say this is point A, velocity at point A will be equal to v naught I cap. If the particle is over here, let's say this is point B, right? then here the velocity of the particle will be called as v naught j cap, right? We had seen this yesterday. Today we'll see how about a circular motion which is a circular motion which is maybe or may not be uniform, right? A general case. So we'll talk about the variation. We'll talk about the variation of acceleration in a short while, right? I think I've okay. I think I've written it mistakenly speed here. Thank you for the correction, Krishna, and I think one more student. Yes, yes. So I think Krishna and Manjunath reminded me I'd mistakenly written uh, speed here. It was acceleration. Plus, please correct it in case you have written it down here. This is acceleration is variable, acceleration is variable, and velocity is variable, whereas speed is constant in a uniform circular motion, right? Thank you for the correction. Thank you. So, class, I will proceed ahead here. So, let's say we have different points on the circle. We are talking about points A, B, C, and the point D, right? And at each point, we have seen how is the velocity varying. The velocity was v naught I cap at A, at B it was v naught j cap, at C it becomes v naught minus I cap, or you can just write minus v naught I cap, and here it becomes minus v naught j cap. So we had seen the velocity, how is it varying. Now let us see the acceleration once again. So acceleration is varying in this format. So acceleration in a uniform circular motion is actually given just by one aspect of it, that is called as centripetal acceleration, right? In a uniform circular motion, you just have centripetal acceleration. It can, so magnitude its magnitude will remain the same, whereas this, its direction will keep changing, right? So just a minute, class. I believe somebody has put on their mics. Please keep your mics off because that might disturb the regular proceedings, right? Thank you. So, class, let us proceed ahead. As I was saying, that have a look. I'll draw with some red color arrows the direction of acceleration at points A, B, and C. See, at point A, it's again towards the center, right? Now at point B, again acceleration is towards the center. At point C, it's towards the center, and at point D, it's towards the center. So although it's towards the center, when you look at the acceleration from the perspective of XY direction, its direction is changing. See here, I will write the values of acceleration at different points. So when it is at point A, the acceleration is v naught square by r j cap, right? Here at B, it is v naught minus v naught square by r I cap. Whereas at C it is directed downwards. Therefore, it's v naught square by r minus j cap, right? So, like along with it, you'll have minus j cap. And these were the components. The one which I have written with blue and black are the components of velocity, whereas these are the respective accelerations at A, B, C, and D, which I'm writing with green color. So here we'll again have C plus at point D plus V naught square by R I cap, right? I hope you all were clear until this point. That see how the acceleration's magnitude is constant, but its direction is changing. Therefore, I say that acceleration is variable in a uniform circular motion. Magnitude constant and direction variable. It's changing at every point of the circular track. So I'll just go one by one from all the pages. Yeah. So class, kindly let me know in case you have any queries with this circular motion aspect of it. Yes, class. Anyone? Anyone, any query, let me know. Okay, if all are clear, let us see a general case now. Suppose we have again a circle, a circular motion taking place, right? Now see how things work. Suppose I do not have, now I talk just about acceleration. So acceleration also has two components, right? One we call as centripetal acceleration or radial acceleration, and the other component, this is one component of it, and the other component is called as tangential acceleration. I'll write this as radial or centripetal, and here this one is called as tangential component of acceleration. So basically, when I'm introducing a new component called tangential component, that is only possible when velocity, uh, so that is only possible when the speed is not constant. See here, when the speed was constant, we can take that tangential acceleration is zero. Also class, one more reminder, we had read yesterday that the magnitude of change in velocity, I'll repeat, magnitude of change in velocity in a uniform circular motion is given as 2v sine theta by 2. I hope you all can recall this from last class, right? You had one of, we had also solved one question from the past years. I think it was some question which had appeared in JEE main, right? uh, yeah. So again, coming back to the general scenario or the general case of circular motion. Here, let speed be varying. Here, let speed be varying. Let us assume that it's not constant, it is changing, right? Now we'll see what will happen to acceleration. See here. So let's say the particle is over here at point A. It will again have two components as I just told. One will be the tangential and the other will be the radial component. Let us first draw the radial component. This is the radial component which I've drawn with brown color. Let me denote this as AC or centripetal acceleration. It is always directed towards the center. Now let us take the tangential component. The tangential component is given as this way. Let us name this as AT, right? Now we have, how do we give the formulas for the two, right? So the centripetal component or the radial component is given as, for acceleration, whatever velocity at that time, v square upon r, v square upon r, where r is the radius of this circular track, right? Now tangential acceleration is actually given as d by dt of velocity, right? See, how can I write this? Because velocity is no longer constant. It is varying, and so basically, even it was varying in the last case, but here I can write this as d by dt of speed rather. Which speed? Tangential speed, because speed is always tangential, right? So class, I'll repeat myself. Centripetal acceleration is given as v square by r, whatever velocity at that point of time, whenever we are calculating v AC. Similarly, AT or tangential acceleration is d by dt of, that is differential of speed or the value of or the magnitude of velocity at that instant of time. So such questions hold a significant place in your papers. Make sure that you have a command over this concept. In case you all want to see an example of it, let me give it for you all. So although it has not been asked in the past years, but there is a probability that this concept will be covered this year. So I will mark this as one of the most probable concept. Again, a double star to this. So yes, coming to the questions for it, for the case of non-uniform circular motion, right? Yes, class. So the question, go ahead. Please write this question. A very simple question and it will give you a very good gist of it. Also, if you'd like to know, how about the direction of AT? Or what? How about how about the direction of net acceleration? So if the net acceleration is made from two components, let's say at point A, I'm just writing at point A, we can write if right direction is telling me x-axis and the vertical direction is telling me y-axis, at point A, that is the bottommost point, I can write net acceleration is equal to AT I cap plus AC J cap, right? After writing this, we can take different ways in which this might be happening. Since we are saying here that speed is variable. So variable means either it is increasing or it is decreasing, right? So let's say case one, when the speed is, let us take this as case by case basis. Let us say the speed is decreasing, then what will happen? If the speed is decreasing, then we will have the value of both of the that is AC and AT will be changing, right? Will be changing. So accordingly, your approach for the question might change, right? Please keep that in mind. There can be two ways possible. Either the speed is increasing or the speed is decreasing. Let's see an example on it. Yeah. So class, let us take an example where the speed is increasing. It says that the question says the velocity of a particle moving along a circular path is given as 2t. The radius of the circular path r the radius of the circular path r is 2 meters, right? You're being told find out its acceleration at t is equal to 2 seconds. Now this is again a probable question, class. Please take this as a probable question in both NEET and JEE, because such questions have not been asked in the previous years, but now they have started asking questions based on circular motion. So they may ask a question this year for NEET 2020. So yeah, try solving it. Can any one of you give me an approach? Anyone? So let me take any one of you. Let's take this time Manjunath. Yes, Manjunath, can you help me with this question? Your approach, how would you solve?
Sir, first of all, I would like to select different. So my approach according to this would be differentiate V.
So first of all, what is our aim, Manjunath? What do we want to find out? Acceleration, right?
Acceleration, yes, sir.
So split acceleration into two components and make it easy. That means acceleration would definitely have two components. One is one is AC, right? And the other is AT, right?
Yes, sir.
Correct? And yesterday we had learned that whenever we have two mutually perpendicular components, we can always write A as AC square plus AT square, right?
Yes, sir.
Manjunath. So if
Yes, sir.
suppose if we find AC and AT separately, our funda will be solved, right? Our purpose will be solved, right? Correct?
Yes, sir.
Tell me what
Yes,
is the
sir.
expression for AC, Manjunath? How do we write centripetal acceleration in terms of velocity? Yes,
AC is equals to V square by R.
square by r. Absolutely correct. And AT is
A differentiation of the velocity given.
the velocity of speed, right? So we are being told about the time t is equal to 2, right? So can we find out the velocity at time t is equal to 2 from the given question? At time, so we already know that in the question it says that velocity is equal to 2t. I write it with a different color. So yeah, we already know that v is equal to 2t, right? So what will be the
Yes,
velocity at time t is equal to 2? 2 into 2, right?
4.
Which is 4 meter per second. Absolutely correct. So once we know the velocity is 4, we'll take it here. 4 square upon r is 2. So you'll have it as 8 meters, right, per second square. Am I correct, Manjunath?
Yes, sir.
Right. Now let us take the next part of it. We'll have AT. How do we calculate AT? By differentiating speed. Do we have speed variable or constant, Manjunath?
The variable, sir.
Variable. Absolutely correct. I'm so happy that today we are able to differentiate this question from the others, right, Manjunath? Yesterday we were on this discussion that how do we actually differentiate whether a quantity is variable or constant. So today we can clearly see that velocity is variable because it depends on time, right, Manjunath?
Yes, sir.
So let us take this as d by dt of 2t, right? What will be the answer?
The 2.
2, right? So you all can see that how we got the tangential component of the acceleration as 2 meter per second square, whereas the radial component as 8 meter per second square. So all we are going to do, yes, Manjunath, how will we find A now? That is the net acceleration component of magnitude of net acceleration. Yes,
So square of 8 and this plus square of 2
right,
under root
right. So we'll take 8 square
plus 2 4 2 square
under root, right? That is 64 and 4, or we'll get it as
under
under
root
root of
68.
8, correct? Which can also be
Yes,
written
sir.
as 2 root of 17 meter per second square. Manjunath, once cross check it and let me know if you clearly understood the concept, and in case we have been right in this approach, yes, just go through it. Class, all of you also please absorb whatever I've just told for this question and let me know if you have any queries. Yes. So Manjunath, are you clear with the approach?
Yes, sir. Yes,
Right?
sir, I'm clear, sir.
All right. Thank you, Manjunath. Thank you.
Thank you, sir.
All right. So class, I hope all of you are clear with this concept, right? Now, for all of us, we have covered almost all the concepts which have been covered for 1D and 2D, right? There is just one concept which we are yet to take, that is the concept of relative velocity. Relative velocity in 1D and 2D. Let's consider that. Class, anybody else who wants to share their any queries or any questions, any suggestions, most welcome. Yes, class, please go ahead. Anyone? So all are clear, right? Great. So now let us see. We have considered circular motion, general case, and uniform circular motion also. We have also seen about how things work when we are talking about a ground to ground projectile, some standard results. How do we calculate radius of trajectory in the yesterday's class? In case you all want me to list it again here, please note that whenever I'm talking about radius of trajectory, suppose I'll just give one short description of it, right? So here, let's say we have a ground to ground projectile, right? A ground to ground projectile. Here we had calculated that if this is a point A and this one is the point C, that is the highest point of the projectile motion. So at point A and point C, there will be something called as radius of curvature, which in order to calculate this, we had used this concept that whenever we are talking about radius, there has to be a circle. So suppose that if the point where we are making the tangent over here, if this tangent or along the direction along which the velocity is oriented, if that is the tangent to a circle, then what would have been the radius of that circle, right? That is called the radius of curvature. I will repeat myself. If we are directing the velocity at a particular direction, let's say at the topmost point, the velocity is along the horizontal, right? So here, if I draw a circle, if I draw a circle which is a tangent to this velocity, what will be the radius of that circle? So in specific, in order to define radius of curvature, we had understood that in a circular motion, always the velocity and the acceleration are perpendicular to each other. Because why? Tangent and radius are perpendicular. So if this is velocity v, this is r. So we had understood that, and this is a, right, and the radius is r for the circle. We had understood that in order to find out r, what formula we'll use. We remember that acceleration is given as v square by r, such that this ac is the component of, it is the component of acceleration which is perpendicular to v, right? This was the key to the entire question. This is the key to the entire concept. What? that whenever we are taking AC is equal to V square by R, we are actually talking about the component of acceleration, because just now we learned that acceleration may have two components. One is AT, that is tangential component, and the other is AC, that is the radial component or the centripetal component of acceleration. So here, what did we do? Let's say, what was the acceleration? Acceleration was the acceleration due to gravity, that is G, working on the particle downwards. So we try to find out what is the component of G which is acting at an angle of 90 degree with the initial velocity at point A in order to get AC over here, right? So we had got, so we told that let us split this G into two components, this G into two components, right? AC and AT. So this would have been AT and this would have been AC. Maybe the figure is not that correct, but then the concept is this is G and we split it into two components which are mutually perpendicular. We call this as AC, we call this as AT, this is G, right? So from the geometry, we see that this is the direction of U with the horizontal as theta. So this angle comes out to be theta. Therefore, the component of acceleration which is perpendicular to U, I will draw that in blue. So see, this is U, right? This is U. Now a component of U, a component of acceleration which is perpendicular to U is AC, and that is given by G cos theta. See here, and AT is G sin theta, right? So we had substituted this in the formula over here, that R is equal to V square upon AC. So at point A or the initial starting point, there U V's or the velocity is nothing but U square, and AC we just obtained it as G cos theta. So this is how we had got the radius of curvature at the initial point of motion. And here, see at point C things are very simple. Why? Because at point C, the velocity is oriented along the x-axis and it's given by Vx. We know that Vx does not change. That is, the horizontal component of velocity is constant for a ground to ground projectile. Why? Because there is no acceleration. Ax is 0. Therefore, Vx is equal to Ux and it's given by U cos theta. Here we have the component of acceleration which is perpendicular to it, because this is horizontal and anything perpendicular to horizontal is nothing but vertical, and already at this point the acceleration is acting downwards in the downwards direction. So at C we have again AC is equal to V square by R. So what will R be equal to? R will be equal to V square by AC, the component of acceleration perpendicular to velocity. So you can clearly see that here directly the entire acceleration, that is entire G, is perpendicular to velocity. So here we have AC directly given by G, and instead of V, we will write U cos theta, right, whole square by G. So we had got radius of curvature at point A as U square upon G cos theta, whereas radius of curvature at point C, or the topmost point, radius of curvature was given as U square cos square theta upon G, right? So we have just revised quickly what we had read yesterday. Class, any queries with this? Just let me know about the concept of radius of curvature or anything else for that matter. Yes. Yes, class. Anybody with any query with this class, previous class, please clear it out. Yes. Before we start, relative velocity. Yes, Manjuna, tell me.
Sir, can you repeat this concept once again, sir?
Okay. So all I want to say that whenever a particle is moving along any curved path, whether be it a parabolic path or a circular path or elliptical path, it will always have a radius of curvature. I'll repeat, it will always have a radius of curvature. So suppose I want to make or understand that what is that radius of curvature, what I'll do, I'll draw a circle here, right, Manjuna? So I'll draw a circle.
Yes, sir.
Let's say if this, what was the velocity at the starting point, Manjunath, at point A? U, right?
You.
And
Yes, sir.
suppose we take it is oriented at an angle of theta from horizontal, right? Now we are
Yes,
seeing
sir.
that, do you know what is the net acceleration acting on any particle when it is allowed to move under gravity? What is the net acceleration acting on it, and what is the direction of it?
So downwards, and the G is acting on it.
Absolutely correct. That on any particle which is free to move under gravity will have the magnitude of G, and its direction is downwards. Now, tell me that, do you see that, is this G perpendicular to you, entirely perpendicular to you? Do you see this? Yes or no? Is it
So,
perpendicular to you?
yes, sir.
Just see, this is the perpendicular, this is you, here is the perpendicular direction. Is G over here, or is G along the blue direction? Try rethinking once again. I'll repeat my question. The question is G perpendicular to you? Are these quantities perpendicular, or is this angle greater than 90? That's the question.
So angle is greater than 90, sir.
Therefore, it is not perpendicular, right?
Yes, sir.
Correct. So the answer is no. It is not perpendicular. So what do we do? So in order to resolve that query, we come up with a concept that the concept that whenever in a circular motion, so now we are relating this projectile motion with a circular motion. We are saying that whenever in a circular motion we had AC is equal to V squared by R. Manjuna, tell me, was this AC perpendicular to V in the circular motion?
So can you repeat, sir?
Yeah, so the question is, when we talk about circular motion, was this AC or the centripetal acceleration perpendicular to the velocity? Was it
Yes,
perpendicular?
sir.
Yes,
Yes,
right.
sir.
So now in order to find out, can we have a component of this acceleration G which is perpendicular to U? We write same formula, AC is equal to V square by R for this projectile motion. And then try to find out what is the component of G which is working in the two directions, one along U, or maybe in the this line of U, and the other perpendicular to U. Manjunath, I'll repeat. I am saying that we just had this G. So we just had this G. I'll write this with orange color here. So we had G, which is working along this blue direction, right, Manjunath?
Yes, sir.
Now I did not know what is the component of G, which is, I'll give it with a spotlight. I did not know what are the components of G which are acting along the line of U and perpendicular to the line of U, right? We do not know this right now. We just know that G has some direction which is not perpendicular to U, right? So we take a
Yes,
decision.
sir.
So we take a decision to make sure that can we have some components of G along the direction of U and perpendicular to U. Is this point clear? We have taken this decision. Okay.
Yes, sir.
Now what do we do? Is
So
that,
we have to find the component of the G.
yes. So what we are doing is now we are finding out what is the component of G in a direction of U and in the direction perpendicular to U. That is what we are doing, right? So we see that this angle, that is, suppose this was the angle which was being made by you with the horizontal. If that angle is theta, so by geometry you find that this angle which u is making with the normal to u, with G is making with the normal to u, is also theta. So what will this component become? G cos theta, right? Correct. And this
Yes, sir.
component which is tangential to the circle will become G sin theta.
Sin theta.
Am I correct, Manjunath? Now are you clear?
Yes, sir.
So we have basically split this G into two components, G sin theta and G cos theta, right? Such that this G cos theta is the component of acceleration which is perpendicular to U. Are you able to relate it now to the circular motion aspect? In the circular motion, we had already acknowledged that centripetal acceleration is perpendicular to velocity, right? And here we are seeing that there is one component of G, that is G cos theta, which is perpendicular to U. And therefore, we are applying the same formula of AC is equal to V square by R, where instead of AC, we will be putting G cos theta. See here, we are putting G cos theta. Are you now clear with this concept? Just try thinking. Just try, take a minute, see what we have done, and then ask again if you have a query. Yes, Manjuna. Have a look at the question once.
Yes, I'm clear.
You're clear?
Yes, sir.
Okay, so can you give a gist of whatever I've said in 2 minutes? Whatever you have understood, think about it and speak. Yes.
Okay. As we have seen in the circular motion, that the acceleration is perpendicular to the tangential velocity.
Which acceleration?
So the same
Which acceleration?
centripetal acceleration.
Centripetal acceleration. Very important. Yes.
Centripetal acceleration is perpendicular to the tangential velocity. So the same we have followed here. At first, we have to find the acceleration,
Uh-huh.
as we know that there are two components of the G will be formed.
Right.
One is the G cos theta, and the other is the G sin theta.
Where is G sine theta along? G sine theta is along the tangent or along the radius?
G sin theta is along the radius, and the G cos theta is along the tangential.
See once again. See once again. See this circle. G sine theta is along.
So G sin theta is along the tangential, sir.
G sine theta is along the tangential. Yes. And the G
Yes,
cos
sir.
theta
Yes.
is along the
Circle. It's a radius, sir.
radius. So G cos theta will be radial acceleration. Yes. Right.
Yes, sir.
So now all you're going to do, instead of AC, you're going to substitute G cos theta. Are you clear now?
Cos theta.
Right? Correct?
Yes, sir.
And what about the point C? Tell us about the point C also. What is happening at point C? Yes. What is the velocity at point C for the particle? Does it have any vertical component or it's just horizontal?
It only have the horizontal component.
Horizontal component. And where is the acceleration acting at point C for the particle? Downwards, right?
Acceleration, yes, sir.
Right? And anything which is acting downwards is already perpendicular to G. So basically the difference between point A, that is the starting point, and the point C, that is the highest point, is that at point C we had to find out what component of G is perpendicular to U, but here we did not do that because the entire G is perpendicular to velocity. Are you able to relate this concept? I will repeat. At the initial point, G was not perpendicular to U. So we found out what component of G is perpendicular to U, and we took that component in this formula. That is R is equal to V square by centripetal acceleration. But when we are talking about the highest point, at that point, the entire G is perpendicular to velocity, right? Therefore, we need not find what component of G is perpendicular to velocity, right, Manjunath?
Yes, sir.
Clear? And therefore instead of AC we need not have the need to substitute any other component. We just substituted the entire G value, right?
Yes, sir. Understood.
Sure. Okay,
Yes, sir.
great. Thank you, Manjunath. Okay.
Thank you, sir.
Okay. Okay. So Harsh, in case you have, I think Harsh has informed me that he's getting some connection issues. So class, just for verification purpose, in order to check if my network is working well, can you all just raise hands in case you are clearly able to hear my voice and see the screen without any interruption? Please raise your hand if the screen is visible clearly to you and if my voice is clearly audible. Yes. Okay. So thank you everyone. Thank you. So I think Harsh, at my end the network is clear. In case there are any network issues at your end, no worries, no worries, Harsh. You can always send me any queries you have via the chat box or on my number. Right? You can send me your queries there. I'll be active, and in case I have any queries get like being received at my end, I'll clear them here itself in the class. No worries, you can do that. Or maybe you can watch these videos. After watching also, if you have any queries, you can put them to me. And the same holds for everybody in the class. Class, in case anybody of you, I understand, right, at this point of time, there might be some of you who might be facing some network issues. No worries. during the class, if you can keep your mobile data active and ask your questions on WhatsApp or any other, like basically on my number, I'll be able to help you out there, right? And in case not, even after the actual class is over, you all can see its video. I'll try to upload the video soon after the class itself. See the video on the uh, channel, that is Physics with Fatnani. Have a look at these videos. Any queries, just send them to me, right, class? So we can discuss it accordingly in the evening practice sessions, right? Okay. So, right now, after this, let us see the concept of relative velocity. One of the concepts which is very much talked about by the students in terms of its understanding uh, depth, right? So we have relative velocity. Let's start. So before we so dear all, I think it was a network error. So all of us will take a 5-minute break and then let's start, right? Okay, class. So class, let's meet at 10:22. It's 10:17 now, right? In 5 minutes, we'll catch up. Let's take a break. Thank you, class. So dear all, in case you are present in the class back, please raise your hand so that we can start off. Thank you, class. You can bring your hands down. Let's begin. So we are talking about the concept of relative velocity. Very simple, right? Just as we talked about velocity, we are talking about relative velocity. Have a look. So first, let us talk in one dimension, right? Let's say there are two objects. One is object A, particle A. Let's say there is another particle B. They both of them have some velocity given as VA and VB respectively, right? Now, the concept of relative velocity says we are actually trying to find out what is the velocity of one body as perceived by person on the other body. So let's say these are two cars, right? And each one of them there is someone who is present on these cars, or maybe they are skateboards and on each one of them there is a person. Now velocity of A with respect to B is given as VA minus VB. Try recalling that with respect to vector quantities, we had assumed that whenever we take them in the positive x direction, we'll take them as positive, negative x direction negative. If they are in upward y direction, they'll be positive. If they are in the downward y direction, they'll be as taken as negative. So you will always write velocity of A with respect to B as VA minus VB with sign. With sign. This is the funda when you talk about one-dimensional motion. When you talk about two-dimensional motion, the vector representation comes into play. Vector representation comes into play, right? So for the vector representation, let us say two bodies now have the velocities, let's say again A and again B, right? Let's say A has velocity VA, right? And let's say B has velocity VB. Again, we will have velocity of A with respect to B is a vector quantity. So it's given as VA minus VB. We need not worry about signs here because they are vector quantities. So the vectors components, the I and J will take care of the sign part, right? So I hope this understanding is clear to all of you, right? So there is one more way of looking at it. Whenever you're talking about velocity of one body with respect to other, we are assuming that what if the other body was not moving? What if the other body was not moving? Or basically the point is we keep the observer on second body, that is on B. So whenever I'm saying with respect to B, I mean with respect to a person who is on B. So with respect to B implies when observer is on B. when observer is on B. That's how you understand the concept of relative velocity, right? Now, you have some questions which have been asked with this regard in the last year's question papers, right? So let us take them up, and I hope these will prove useful to all of you. So yeah, let's get going. So the question asked, all of you note it down. This is basically one of the very much talked about river swimmer problem or river boat problem. River swimmer question, right? Now let's say you have, so this question is from question number from year again 2019, right? Now here what was the question? You have a river, flowing, let's say in the right direction, okay? So let me take an arrow which denotes the direction of flow of river, right? So this is the direction of flow of river. Now it is saying that the question is saying, listen carefully. The question is saying that the stream of a river is flowing with a speed of 2 kilometer per hour. I'll write it here. The velocity of river is 2 kilometer per hour, right? This is what is given. In fact, you can call it as speed because I'm just writing the magnitude. Now, a swimmer can swim at a speed of the speed of the swimmer. I'll denote swimmer by S, and a speed by Vs is given as 4 kilometer per hour. This is how a swimmer can swim. You are being told what should be the direction of swimmer, what should be the direction of swimmer. Jot it down with you. What should be the direction of swimmer with respect to the flow of river? See, with respect to WRT, with respect to the flow of the river. The flow of the river. So, in order to cross the river straight, so as to cross the river straight. See, you know, some students try to mug up the formula. Again, I will say, do not mug up the formula for this question at all, right? This question, please do not mug up the formula. Understand, if you are clear with the concept, in a minute you will be able to crack this question. See how. Let's say the swimmer is here, right? Now, what is his intention? His intention is to cross the river straight. See here, I'll underline the word cross the river, underline the phrase cross the river straight. That means he does not want to deviate. What is the river trying to do? See, let's say, I'll just explain the concept first. So let's say he tries to move in this direction. This is his intention, right? So I will write it here. This is his intended path. Intended path. This is how you want to go, right? Now, see what will happen. I'll draw this figure over here again. So this is the river. Again, different cases we'll take up. Okay. What will happen, in which direction the swimmer should go, and what is the river doing to him, right? So suppose the swimmer, this is the swimmer, I'll draw him in red. So this is the swimmer. What he does is, suppose he directly starts in this direction. So I'll draw it with an arrow. So let's say, this is how. Let's say he starts in this direction. Suppose he goes straight, but what will the river do? It is not a lake, it is a river, right? River has its own flow. We have been given in the question that the river has a velocity of 2 kilometer per hour. So when the man jumps into the river, the man also gains this horizontal component of velocity, which is 2 kilometer per hour. So if the river is flowing towards right, the man will get a velocity by himself which is already there, that is velocity of the swimmer, right, which is in the straight direction. Not only this, but he'll also get a horizontal component of the velocity. I will repeat. The man is trying to go straight, but as soon as he goes into the river provides him with a horizontal component also. Now, as the river is giving this man a horizontal component of velocity, so the man will not end up coming over here. Rather, the man will get deviated from its path and will end up over here. This is what happens. If the man tries to go in the direct straight path, he will not be able to reach this because he will get a horizontal component of velocity. He will end up getting deviated from its path by some value. But this is not what he wants to do. So what to do in a scenario of this sort? In a scenario of this sort, he'll apply a trick. He'll say, I know physics well, right? He'll say, I am a very good physicist. So I'll apply some fundas of physics and I'll do a very I'll I'll be very tricky and I will rather go in this direction. See here, he'll say I'll go in the other direction, that is in the opposite direction of the river. So he will basically try to put the reverse flow to his advantage. I will repeat, he will basically try to put the reverse flow to his advantage. The river is flowing towards right. The river is flowing in this direction. Rather, so when he starts moving over here, what happens? He will have again two components to his velocity. One is straight forward and the other is straight backward, right? He'll have two components to his velocity. Why is he giving this horizontal component backwards? Because he want to tackle this component of the velocity which is being given by the river is trying to pull him towards right. So he'll do one thing, he'll provide himself with a horizontal component backwards, right? Horizontal component backwards. So I think one of you has sent the answers. The answer has been sent by Shivani. Shivani is saying 30 degree towards left. Yes, Shivani, you are absolutely correct. So basically, the point is, in order to shift himself, in order to make himself reach directly over here, shift himself just cross straight, he will actually tend to go in a direction a little against the river, right? He'll try to go in a direction little against the river. This will actually provide him the necessary condition to reach straight. So you are being asked in the question, see here the question now, what should be the direction of swimmer with respect to the flow of the river to cross the river straight? So you're being asked with respect to the river. So if this is the velocity of river and this is the velocity of man, see here, this is velocity of river, right? In the right? And with the blue arrow I have shown what should be the direction of swimmer. So we have to find this angle. See, this angle. We have in the question we are supposed to find out what should this angle be, right? Now, very simple. See here, we will write, basically we'll make a triangle, this triangle which I've already drawn here. Have a look, I'll highlight it with a spotlight, this triangle, this and this, right? Now what is happening in this triangle? I'll show it over here, maybe in this third figure. So in this triangle I'll draw again, this is the final decided velocity. He will decide that he'll go against the river so that he ends up reaching. So this is his actual direction. This will be his actual direction for the swimmer, right? Actual direction for swimmer. And why is he doing this? So that he ends up straight. See here, so that he ends up straight across the other end of the river. And what is the direction of river? The direction of river is in right, that is, see here, I'm drawing it with an orange arrowhead over here, see, or maybe I'll take another color, say maybe red color. Yeah, have a look. So this red tells me the direction of river. This red arrow tells me the direction of river flow. Direction of flow of the river, right? And this black one tells me the intended direction of the man. Intended direction of the man. Right? So now we have understood how this triangle be like. Let us say this angle is theta, right? We know what is the velocity of the man. So let's say the size of the arrow is representing the velocity of the man or the speed of the man, that is 4 kilometer per hour, right? The length of this blue arrow, and the velocity of river is already known, that is this is 2. So from this triangle, see, can you find theta? Try finding it out. Let's say we write sine theta from this triangle. Sine theta, right? So sine theta is perpendicular by hypotenuse, that is 2 upon 4. That will give us 1 by 2. So we'll write theta is equal to 30 degrees, right? So this theta is 30 degrees. So the theta which we wanted to find out. So for the sake of convenience of everybody, rather than writing theta here, let us say alpha is the actual angle asked, right? So in the question, what we are being asked is the angle alpha, right? Which is this, the direction which the man makes with the direction of river, the angle which the man makes with the direction of river. That is the angle between this blue color arrow and this pink color line, right? We want to find out this angle alpha. Theta comes out to be 30. Theta is 30 and this angle is 90. It is very clearly visible that alpha is equal to theta or 30 plus 90, which gives me 120 degrees. In essence, the man makes an angle of 120 degree. This man makes an angle of 120 degree over here. This angle, he'll go this way with the direction of river, so that he ends up reaching over here, right? Class, take a minute and observe this question for a minute. Whatever we did, our answer comes out to be 120 degrees, right? This is the answer. In case you have any queries, you may let me know. So just observe this question for a minute. I'll leave you all with a question. Observe, raise your hand once you are clear with the concept and whatever you have written on the board. Raise your hand once you are clear with the concept. Yes, class. All right, so I can see that most of you have understood. I think Harsh, Krishna, and Pratham have some queries. Okay, Krishna and Pratham have also raised hand. Harsh, in case, okay, I think there is some network issue at Harsh's end. Harsh, you can send me your queries by message or on Zoom or on directly on my number. Thank you, everyone. Let's move to the next concept then. Thanks all. Thank you. You can bring your hands down. All right, class. So let us take one question now, again from this concept, right? Yeah, right. Class, there is some concept that I want to take up with you all. Very interesting and at the same time challenging, right? So let's see if you all are able to take it up. This is a short test. If you are able to, if you all have able to understood the concepts told by me. Before I start that, yes. So you're being told in the question that you're being told in the question that you have a particle is projected at an angle. A particle is projected at an angle a concept a little different from relative velocity but really important in this motion in 2D aspect. A particle is projected at an angle theta, right? At the angle theta from the ground, from horizontal or ground. Now you're being asked the slope of the trajectory. Slope of the trajectory. Trajectory is the path which the particle will follow. The slope of the trajectory, suppose that is m, right? So how does it vary with time? Varies with time as, now you have to identify how does the slope of the trajectory vary with time. So I am going to give you options here. This is again one of the questions which is very probable in the coming year. Class, please take a note of it. This question is probable for JEE and NEET 2020. Again, a very probable question. You will not find many such questions here and there, so please take it up, right? So you have, right, you have options given as, I'll give you 4 options. There are 4 options here which are basically graphs between slope of the trajectory m and the time t. I'll name them as options A, B, C, D. A, B, C, and D. And let me write them here as in the form of different graphs. So this is first one. This is M and this is T, right? We are plotting graphs between slope of the trajectory and the time. You are given with 4 options. This is the first graph. These are the next graphs. Have a look. This is somewhat a curved nature of graph. This is again somewhat like a downward parabola, right? And here this is an upward parabola. I hope you all are very well aware with what is the equation of parabola, etc. In case you have any doubt with regards to parabola and the other curves that are there, you may simply ask me, no worries. Yeah. Yes, class. Take 2 minutes. It's 10:46 now. In case you're able to crack this up, I'll be really happy. Let's see. Yes, class. Get going. In fact, I'll be very happy even if you're not able to crack it up, because then we'll see how to deal such questions. Yes. The hint, if you all want the hint, in case anybody wants the hint, please raise hand. I'll give the hint also in case you need it. Yes, class. If anybody wants hint, please raise your hand so that I'll give the hint also. Okay. So I guess there are 3 students asking for it. I'll give the hint. So the hint is recall equation of trajectory. We had read about trajectory, right? Trajectory equation. Recall that equation and use it to find slope. This is the hint. In fact, I have revealed the entire key of the question. Get going. Yes. Yes, class. Get going. Yes, so I think we have crossed the 2 minute limit. So those who would like to give me or help me with solving this question, please raise your hand. Let's see. Please raise your hand if you would like to help me with solving the question. I think only one hand is raised, Monica. Anybody else, class, who would like to help me with solving this question? Anyone? Okay, so we have three hands up. Okay, we have two hands up, Siddharth and Mahila. Okay, so let us take Mahila. Yes, Mahila, go ahead. Okay, so I have all hands down. Okay, no worries. Class C, have a look. So we are being told that the particle is projected at an angle theta from the horizontal, right? So as soon as that is being said to us, we are very clear that what is happening is this is nothing but the case of a ground to ground projectile, right? This is one thing which should come into our mind at that moment. As soon as we read this statement, projected at an angle theta. As soon as we read this, we should be able to understand that it is a ground to ground projectile case, right? So very simple. This is a ground to ground projectile case. This manner, the ball has been projected at an angle theta, right? Just now with Shivani, we had solved a question. If you all can remember, right? We had written this equation in order to write the equation of the curve, this trajectory, the one which I have drawn here in the dotted line. This trajectory is basically that of a parabola, which is written in this format. See here, we write this as y is equal to x tan theta, y is equal to x tan theta times of 1 minus x by r, right? 1 minus x by r. This is the equation of trajectory. Equation of trajectory, and this case is ground to ground projectile. Ground to ground projectile. So I would still want to take help from one of you. So let's take Siddharth. Yes, Siddharth. So Siddharth, let me know, how do you define slope of any equation?
Sir,
Suppose I give you y is equal to x square plus x. How will you find out the slope?
so we differentiate
Differentiated. Let me know, what does it give us?
2x plus 1.
Plus 1. Absolutely correct. Now, similarly, you have this another as another equation. You have y in terms
Yes,
of
sir.
x, right? Let's first write it in the expanded format. That is, y is equal to x tan theta minus x square tan theta upon r, right?
By r. Yes, sir.
Now, tell me, Siddharth, once the
Yes,
ball
sir.
has been projected, this theta, if I call this as initial angle of projection, angle of maybe angle of projection or initial angle which the velocity makes with the horizontal. So
Yes, sir.
will this theta be variable with time or will it remain constant? If I'm saying
No,
that,
sir, it will remain constant after the first projection.
yeah, once again. Yes, Siddharth. So what will happen is, will this theta vary or will this theta remain constant?
It will remain constant, sir.
It will remain constant, right? Because I am saying that this is the angle which the initial velocity was making, right?
Initial
So
velocity.
theta does not vary with time, right? Does not vary
Time.
with time. It is constant. Okay. Now,
Yes, sir.
second question. How about the range? Does the range vary with time or is it a constant value?
So the range is also constant value.
Yes. Tell me the formula for range we had read.
Uh,
2
one
times
second.
ux
2
uy
times ux uy by g.
g, right? Now this u is
Yes,
given
sir.
as u ux is given as u cos theta,
U cos theta and
y
u
is
sin theta.
u sin theta, right? Now that we have u x and uy given, you have, so tell me, is u constant or is u variable?
U is constant, sir,
U is constant.
because it's the initial velocity of the
Yes,
projection.
because it's the initial velocity of projectile. Theta is also constant, right?
Yes, sir.
What does this imply? That a variable which is depending upon u and theta. If u and theta are constant, that variable will also be constant, right?
Be constant. Yes, sir.
Right. Therefore, r is a constant. Therefore, tan theta is also a constant because theta is constant, right?
Theta is constant. Yes, sir.
Let us take the ratio of the two of them as k. Can we take it now that as a constant value?
Yes, sir.
Right? So, or maybe even better, let us now write this equation as ax minus bx square. Can I write it this way?
Bx squared.
Correct?
Yes, sir.
Where a and b are constants. A and b are constant. Can we write it this way, Siddharth?
Yes, sir.
Correct? Now, can you find the slope of this equation the way you found the slope of the given equation? Yes. Tell me.
We get a minus 2bx, sir.
Absolutely correct. We'll get dy by dx is equal to a minus 2
A minus 2bx.
x, right?
Yes, sir.
Now, this slope, this
This
is
is the
the slope,
slope.
right? That is m, right? Now, what is the
Yes, sir.
question asking you? Siddharth, read the question again. This part, what is being asked? This from here. Yes.
Sir, we're being asked for the uh, the graph of the slope of the trajectory.
No,
So the variation with time. So when we differentiate with respect to t, the slope of the trajectory that we obtained, like a minus 2bx, when we differentiate that, we're going to get the answer. That's what they're asking for.
so we are being asked what is the graph between m, that is the slope, right? And slope is nothing but dy by dx for the trajectory. If the trajectory equation
Yes, sir.
is an equation in terms of y and x, the slope will be dy by dx, right?
dy by dx. Yes, sir.
So this m is nothing but dy by dx, correct?
Yes, sir.
Right? And now we are being asked what is the graph between dy by dx and time, right?
Yes, sir.
We have understood here that dy by dx or slope is equal to a minus 2b. So we are basically seeing that
2bx. Yes, sir.
we can find out the relation between dy by dx and x, right?
Yes,
Correct?
sir.
So now that relation is obviously seeming it's a linear straight line relation, right?
Linear straight line.
Right?
Yes, sir.
That is linear straight line relation, but this is the relation between dy by dx and x. Whereas
X.
what are we being asked? The relation between dy by
dy
dx
by dx
time,
and
not
t.
x, right? So we will see, can we write this x in terms of t? Can we write this x in terms of t?
Yes, sir.
So in order to do that, let us do it on next page. So we have attained that dy by dx is equal to some constant a minus 2bx. A
Yes, sir.
minus 2bx. Now we are
2bx.
seeing, suppose we were asked that plot a graph between the slope of the trajectory. Plot a graph between the slope of the trajectory and
The
the
slope of the
horizontal distance covered. Suppose that was asked. So we would have taken this line as in the form of y is equal to mx plus c, where
Uh,
m would have been negative. So it would have been a falling curve, something,
minus 2b.
right? So something
Yes,
like,
sir.
right? So that
Yes, sir.
this would have been our approach towards the solution, were provided we were asked that plot a graph between the slope of the trajectory
Slope of the trajectory
and
and horizontal distance.
but
Yes,
that is not the question. Question is about the graph between dy by dx and
and t.
t. Let's see if x is depending on t. Just some time back when we were discussing this question with Shivani, I think that question has got erased. So that question we had understood that we take for x and y direction separately this equation s is equal to ut plus half at square.
Plus half 80 squared.
By recalling,
Yes, sir.
for the x direction we had ax is equal to 0 and therefore s was
0.
equal to x given as ux into t. Do you remember this, Siddharth?
Yes, sir.
Now,
So I'll just write that down.
yes,
Yeah.
ux was equal to u naught or u whatever cos theta, right?
Yes, sir.
And you just agreed sometime before that u and cos theta both are constants, right?
Are constants.
So
Yes,
I
sir.
can write maybe this as some constant c into t, right, Siddharth?
Yes, sir.
What am I writing some constant into t? the value of x.
U cost the value of x.
X, right? So we will write the same over here. See, instead of x, we will substitute some constant c into t, correct? So what will this
Yes, sir.
equation become now? This equation will become dy by dx given as a minus
Minus
b,
2bct.
right? Correct?
Yes, sir.
Which we can simply write as a minus k naught t, correct? A
Yes, sir.
minus k naught t. Am I clear, Siddharth?
Yes, sir. And now it's in the straight line form.
Yes.
So
Again,
that's
we
going to
have
be a.
found that the slope or m is depending upon t in a straight line format. And here the slope of the line, that is this value minus k naught, of course, is negative. So we will take,
Negative, so it will be a falling curve.
so it is again a falling curve. So suppose now we plot a graph between, now this time m, that is dy by dx, the slope of the trajectory, and time, we'll again get this as a straight line which is falling downwards, right?
Yes, sir.
Something like this. Am I correct, Siddharth?
Yes, sir.
So I'll repeat it for your understanding once again. We were given in the question that you have a projectile which is projected at an angle of theta from the horizontal. We were told to plot a graph between the slope of the trajectory m varying with time t. Now, in order
Varying with time t as.
what was the approach, Siddharth? Tell me this question in your words in 2 minutes, quick. Yes, go ahead.
So we took the trajectory formula from like I think yesterday's or day before yesterday's lesson.
Yes.
We differentiated that to get the slope of the
Yes.
trajectory.
So basically, first step was to write down the equation of the trajectory where we write y is equal to x tan theta times of 1 minus x by r, where theta is the initial angle of projection. X and y are the coordinates of the point where the particle is present at any given time t. Class, I will repeat,
Yes, sir.
x and y are the coordinates of any given point at time, random time t, right? If the particle is assumed to start its motion from origin, right? And this r is nothing but the range which we had read yesterday. Yes, Siddharth, go ahead. So after writing the trajectory equation, what did we do?
We differentiated it to get the slope of the trajectory.
We differentiated it to get the slope of the trajectory, right? So I think we have differentiated here and we got this equation. Okay, Siddharth, what next?
So after that, we represented x in terms of t because that's what the question asked. The relation with time.
Right. So then we try to understand how is this x depending upon time, and it clearly comes
Time.
out that this x is linearly dependent on time, given as x is
Linearly
equal to
dependent on
u
time.
naught u cos theta into t, where u and theta both are constant with time because they are properties of that motion at initial instant of time, right? So basically u,
Yes, sir.
what is u? U is the value of velocity at time t is equal to 0, right? So therefore this u is constant. Suppose randomly we say that the angle which velocity makes with horizontal is alpha, right? So at time t is equal to 0, this value of alpha is equal to theta, right? So basically theta is again the initial value of the angle being made by the velocity with
By the
horizontal,
velocity.
right? So therefore we came to an understanding that both theta and u are constant, so we can bring them in the form of a constant, let's say c,
Of a constant c.
right? So we got x is equal to some function of t, x is equal to ct. Then we substituted it over here to get this equation, m is equal to a minus k naught t.
K naught t.
Right. So are we clear with this, Siddharth? Are we clear with the concept?
Yes, sir.
Very clear.
Yes, sir.
All right. Thank you, Siddharth.
Thanks, sir.
So class, everyone who has understood this concept well, please raise your hand so that we can move to the next part. Yes. If you have understood this concept well, please raise your hand in order to give me a signal that we can proceed ahead. Yes, class. So this was the question. This is page number 1 and this is page number 2 of the solution. Yes, class, please raise your hand so that I'll know that you have understood this concept. Okay, everyone have raised their hands. All right. Right. Thank you, everyone. Right. Thank you, class. You can bring your hands down. Right. So with this, we have covered almost different kind of concepts which have been taken. Right. I'll leave you all with a homework for the day. Right. The homework is over here. Have a look. This is again a question from the year JEE 2019. The question says something and we are going to take it up. Let's see how are you able to solve this question. This question is based on the concept of relative velocity. If you all need a hint, I'll give you that, but please write the question with you. The question says that a ship A, that is the name of the ship is ship A, is sailing towards northeast with velocity v is equal to 30 I cap plus 50 j cap, where I is east, I denotes east, right, and j denotes north. After this, the question says that there is another ship called ship B. The ship B is at a distance of 80 kilometers east and 150 kilometers north of ship A. This N is north, E is east, right? So 80 kilometers east and 150 kilometers north of ship A, and is sailing towards west. W is west, right? At sailing towards west at 10 kilometer per hour. You are being asked what is or will be minimum distance, or in fact I will tweak the question a little. You have A and B are at minimum distance from each other at first at what time, so this was what was asked in the paper, and I am giving you an additional part to it. And the part is, what is that minimum distance? What is that minimum distance? What is that minimum distance and what is the time at which A and B are at that minimum distance? This is east, I cap, this is north, J cap, right? The hint is you can consider A is at origin. Hint is, this is hint at my end, you may consider A is at origin, this point O, right? From here, start building upon this question do not hurry and do not start on the impression that this is a JEE main question, you may or may not be able to make it. No, go with the question in the flow. Try relating the concept which we have read until now. I think you all remember that this minimum concept we had read in the application of differentiation. In the application of differentiation, we had come up with this minimum question. Try recalling. We had written y is equal to sine theta plus root 3 cos theta, and we had tried to find out that what is the value of y minimum. I hope you all remember this, right? So this is that application of um, differentiation which will come here, but before that you have to apply your brains and think that how you have to go with it, right? So thank you, class. Thank you very much. Please jot this down, this question with you. Please jot this question with you, and thank you very much. We'll meet tomorrow same time, and before that we'll meet today for the practice session in the evening. We'll also cover some part of the next chapter maybe in the class today evening. Thank you very much. Thank you.